Hi, let's solving this probability problems. Okay, before you solving this, I already discussed the list of formula in another video, right? So for this video, I can just teach you how to solving this problems by using all the formula given. So, okay, so given that A and B are two events, alright, are two events. So, and such that the probability of event A is 0.4 and probability of B given A, right? This is a conditional probability. B given that A is 0.7 and P complement of A intersect with B will be 0.3, and they are asking you to find the probability of A intersect with B. So of course we need some formula here, as we have we having PB given A, right? PB given A is defined to be the probability of event A intersect with event A divided by the probability of event A, right? So from here we can actually find the A intersect B. So B intersect A and A intersect B are representing the same thing. So PA intersect B and divided by probability of A, right? It's defined to be probability of B given A. So as PB given A is already given as 0.7, right? 0.7. So PA intersect B, right? A intersect B. So what we want is we want to find probability of event A intersection with event B. So, and you know that probability of event A will be 0.4, right? 0.4. So from here you can find the probability of A intersect B, which will give you 0.7 multiplied with 0.4, right? So let's see what you will get. So you are getting 0.28. So, and this is how we find the probability of A intersect B. Alright, look at the next question. They're asking you to find the probability of event B, right? So as we already have the answer for probability of A intersect with B, right? So let's see what information can be used, right? So it's given this information here. So we know that complement of A or A prime intersect with B is 0.3, right? And the formula for this exclusion principle, so we can actually taking the probability of B, so minus with the probability of A intersect B, right? As you want the B, the event B, the element, but you don't want the one that the B share with the A, right? So A prime intersect with B. So, and for this you are getting 0.3, right? As you know the formula, you must know the formula very well, as this is the formula, right? For this. So, and you have probability of A intersect with B, right? Event A intersect with B, then you will have probability of B. You can find probability of B easily by just using the intersection, right? The probability of A intersect with B, right? So therefore the probability of event B will be the same as 0.3 plus with 0.28, which gives you 0.58, right? As easy as that. All right. Right. Let's continue with part C. So where they wanted to find the probability of A union with B, right? Now the event A union with event B. So you know that these two events is not mutually exclusive, because you see there is the probability A intersect B, which is not zero, right? This is not a mutually exclusive event. So, or then we can apply the formula, right? Apply formula for A union B, which will be PA plus with probability of event B minus with probability of A intersect with B. So then you can have all the information given, right? You have probability of A 0.4, probability of B 0.58 minus with probability of A intersect B 0.28. By calculating this, you will get your answer. Alright, which giving you 0.7. So the probability of A union B. Alright, later in the question, they're asking you to find the probability of A given B, the conditional probability of A given B. So then you know that probability of A given B is defined to be probability of A intersect with B divided by probability of B, right? So probability of A intersect B will be 0.28, right? 0.28, and probability of B is 0.58, right? A intersect B is 0.28 and probability of B is 0.58. So then you can calculate the value, which will giving you 14 over 29, right? 14 over 29. It's better leave in fraction form for this case. So means that the probability of A given B will be 14 over 29, right? Okay, let's look at the next. Alright, okay. Then the question asking you to state with reason, right, whether events A and B are independent. Alright, so if you know that if it's independent, so it means that the outcome of one event does not affect the outcome of the other event. For example, means that if I said that A given B, right, will not happen, alright, it will not depend on the other event, so which is the probability of A, right? So it means that PA given B will be equals to PA, will be independent of B, or I can say that the probability of B given A is not depend on A, right? It's not depend on A, so it's the probability of B itself, right? This is a way of verify, right? How to verify that the events are independent or not, right? So secondly, follow through this. So actually you know that if these two events if event A and event B are independent, alright, if event A and event B are independent, this is case happen when they are independent. So when they're independent, they will follow the multiplication, right? Means that the A intersect with B will be equals to probability of A, the probability of A multiplied with probability of B, right? This is also another way of verify that I already explained this in another video where I explain why is this happen. It's because due to the first, right? So now these two is enough. It's used to verify whether the event A and B are independent or not. So, alright, usually I will suggest to using this, okay? Either one is alright, okay? As you know that PA given B is 14 over 29, right? So does it is the same as PA, right? If it's independent, the probability of A given B is the same as the probability of event A, right? If you look at this, 14 over 29 is not the same as 0.4. Right? It's not the same as 0.4. This is already tell us that A is not independent. A and B are not independent, or we said they are dependent. Alright, or I can do some calculation, right? As you know that the probability of A given A intersect B will be 0.28, right? 0.28. So, and the probability of A, right? Probability of A multiply the probability of B. So probability of A will be 0.4 and the probability of B is 0.58. So if you calculate, you are getting 0.232, right? 0.232. So means that these two events, A and B are not independent. The reason is because they never follow this, right? So I use this the second method to verify, all right? To determine whether the two events are independent or not. So you look at here, the probability of A intersect with B will be 0.28, but the probability of A multiplied with the probability of B is 0.232. So which is not equal, right? The reason very simple, as the probability of A intersect B is not the same as the probability of A multiplied with the probability of B, right? So therefore, because since the probability of A intersect B is not the same as the probability of A multiplied by the probability of B, therefore events A and B are not independent, right? Events A and B are not independent, or we said are dependent. They are depend to each other, means that A depend on B and B depend on A. A very simple way of doing this question here. All right, let's go for more examples about this type of problems.